Hi everyone, I'm David Pike. I'm here with RS Components to have an Ask the Expert conversation for Design Spark. We're going to talk about industrial connectivity with Jeff Barnes from Molex. So Jeff, if you could introduce yourself.
Hi, David. Yeah, I'm Jeff Barnes. I'm the distribution corporate manager for Europe for the industrial range from Molex.
Fantastic. Industrial is a big topic for us at the moment. There's a lot of developments going on. So thinking about the industrial environment and the factory floor, what is it that we need to be dealing with here?
So, yeah, with Industry 4.0, with Smart Factory, with Industry IIoT, there's a lot of things that are being put into the marketplace. Most of these are to generate more data, to make the production more efficient, more flexible, and produce better components in a faster way.
Okay, but at the same time, we're still talking about the factory floor, which is a pretty harsh environment, really. So we're talking about putting lots of extra sophistication into the factory floor. What impact has that got for equipment and for connectivity as a whole?
But depending on the factory itself, whether it's a food and beverage factory and dry food, wet food is different environments, whether you've got a production plant and manufacturing cars or whether you're baking packaging. There's lots of different environments that the connectivity live in. But the predominant connectivity that people are looking at is the IP67 for the standard areas and then IP69K for the wet food areas.
Okay, so what does this factory look like? We're talking about computers, machines, sensors. What kind of structure is this new factory going to take?
Well, the way it's looking at, with the data set that's coming in, if you look at a machine is pretty basic. If you look at it like a human being, you have a PLC, which is a brain, you have structure there, which could be the skeletons, you've got pneumatics, you've got hydraulics, which could be circulation, you've got motors, robots, servos, those sort of things that are adding motion. What we are as Molex, we're the connectivity, so we're the nervous system of the machine. And as the machines progress, it doesn't really matter what they're making. They could be making soda bottles, they could be making paint, it could be making chewing gum. It doesn't really matter. The architecture of the machines are the same. And as we approach into this Industry 4.0, so we're bringing more and more connectivity up into a cloud-based system. So, for example, a good use of that would be we're making bread. And depending on what we're making, it could be loaves of bread, could be wholemeal, could be white buns or whatever. So we need to adjust the machine in a very quick, easy way where we can feed different types of product through that machine and also speak into the ERP systems of the factory that are then directly connected to the suppliers of the flour, of the eggs, of whatever it is. So it's not a manual task now to look at the difference of availability of the raw materials. So they could send a signal into the flour mill to say, hey, we've got a bit of an uplift on a particular type of bread. We need more wholemeal flour. That will automatically come in, get booked in and be there on time rather than a lot of manual process. And to do that, we have a lot of IT to OT. So IT, we all know the IT world. I mean, it's what we use predominantly day to day. But within a factory, you've got the operational technology. So this is the Ethernet-based network that's running around the factory that's connecting all of these machines together and talking up into an IT database or something else. And
So,
that's really developing.
so I'm guessing we're talking about a huge explosion in the amount of data that's being channeled around the factory. Is that correct?
Yeah, more and more engineers are looking at, what data can I have? And they're not limited now just to, vibration, it reaches a vibration level. okay, I want to know before it reaches the vibration level. I want to see if there's a significant change, or if things are moving in a direction that I want to go in there and do some preventative maintenance on. So I'm not waiting for it to signal me to fail. It's already telling me that, hey, there's a problem on line 3. You need to maybe go and have a look at that. So the engineers can be more efficient within their machine and taking care of their machines. And it's all down to the amount of data that we can pull out. And with engineers, you give them a list of data that they can have. They want it all, whether they want it or need it or use it or how they're going to visualize it. They want it all. And then they'll decide, once they've got it all, what they need and what they don't need.
So I'm guessing that means also, amongst anything else, a big increase in the number and sophistication of the sensors, because it sounds like a lot of this information gathering is going to very much depend on sensors in excess of what we've used in the past.
Yeah, the sensors are just going, up and up and up, and the technology in the sensors, the intelligence in the sensors is increasing all the time. The continue, and we've got to get all of that information back. It was, a few years ago that if you had a capacitive sensor or an inductive sensor, you'd have to adjust manually what the range was. This range now can be held within the controller. And so all they have to do is take the sensor off. If it fails, put a new one on, and the system will automatically configure that sensor. So it's a lot of de-skilling in a way, but it just makes things far more efficient and super fast in getting machines back up and running.
So we've got an increase in the number of sensors, an increase in the number of machines that are communicating back to the IT level where it's holding all this information. Plus, we've got this environment that can be quite tough with IP67 requirements. What is this doing to how we select our connector? What does this mean about the form, fit, and function of the connectors for this environment?
Well, with the Brad from Molex connectors, we do the standard M12 connectors, we do the M8s, the full range of connectors, which I know you have some there.
Yeah.
And what we've done is we developed several years ago a product called Ultralock. This is now, the patent and everything is now gone out into other manufacturers together, and that's now become an IEC standard. So what does that actually mean? Well, instead of a threaded, screw down connector where you may have an IP issue if you don't tighten it up enough, or if you over tighten it, you can damage the O-ring seal in the bottom of the receptacle. This is a push-pull blind mate fit. So it's a very quick, easy way of connecting the connectors into an IO block or a sensor or whatever as it moves forwards. And with the Ultralock 2.0, which we're developing in association with this IEC standard now, it's actually going to be a cost down from our standard Ultralock. So we're reducing the cost into there. So I think as it moves forward and as it gets launched and as other manufacturers are picking up on this as well and launching their versions, so this will become the standard moving forward. Because if you imagine, a small machine, it's got, I don't know, 200 IO. So that could be 200 sensors out in the field, each one with an M12 connector or an M8 connector that they have to plug in and screw in. That's a lot of time to put all those together. And if we can just do a quick push-pull speed fit connector, then it's reducing that time. The other way of reducing time on the machines is actually in the machine builders. So a lot of the machines historically have been what we call hardwired. So what does that mean? There's our sensor, and we'll have a run of cable all the way back threaded through the machine to the control cabinet. And then we'll connect it in the control cabinet with a row of terminals. And then from there, we'll connect from the terminals up into the controller. So that's a lot of connections. If you think about a standard sensor, just a basic on-off sensor, it's going to have 3 cables. It's going to have your two power cables and your signal. So that's 3 times that by 200. That's 600 connections that you've got to strip, terminate, put a ferrule on. You've got to have, a bank of terminal strips that you've got to connect into. And then you have the 600 connections in the cabinet connecting into the top of the terminal, and then the 600 connections connecting up into the PLC. Boy, that's a lot of time. That's a lot of time just to do a very simple machine. 200 connections is not, or 200 sensors is not a large machine by any shape of the imagination. So, what we're seeing is a trend towards a more modular type system. So we've got our MPIS box, which is
something like this.
Well, the other one, David, the one with the connector on it.
Right.
Yeah, so it's a passive box. It's not.
So something like this.
That's it. That's the one. Yeah. So what that does is that brings the connectivity for all of the power and all of the sensors into one multi-core cable, which they run back, and it reduces the number of connections. Because like an extension lead, a power standard extension lead, we're commoning the power. So we have for 8 sensors, we'll have 3. So we'll for the positive, negative, and the ground, and then we'll have 8 sensor connections, for signal. So that's 11 wires for 8 sensors, as opposed to 8 sensors times 3 wires if you hardwire it.
And not just 3 wires, but 3 wires over a very long distance.
Over a long distance, yeah. And there's a lot of other things that they can look at with that. With the one you show, we do 2 different versions. One is with a molded in home run cable, and we have that connector cable. So if they need to split the machine down for shipping or whatever they need to do as they move forwards, so they can just take one connector off, leave all the other connections made up, roll that connector back into the cabinet, and when they plug it back in, when they get to site, it's all connected and everything is ready to go. So there's a lot of decommissioning time reduction there as well. And then what we're seeing is more now is the approach into the network-based systems. So we have an Ethernet IP, we have Profinet, we have all sorts of, they're the 2 main ones moving forwards. And that then brings the other block that you showed, which is the IO. So it's actually a active block. So that takes all of those signals, all of that power, and it brings it over an Ethernet-based system. And we can have 256 of those blocks connected through one RJ45 connector in the cabinet. So that's all of those signals, 256 times 8.
Yeah, all that stuff.
Or
plus
by
a load more.
actually 16, because we can actually double those up in those blocks as well. So we can bring 2 sensors into one port. So, it's 4,096 connections through one RJ45, and then 5 connections for power. So if you look at the time that can actually be saved in using that modularity, it's huge for the machine builder, and it's huge for when it's on site and there's an issue or fault finding or anything like that. I'm sure you've the same as me. If you've ever opened a cabinet that's been in position for quite a while in a factory, it's a rat's nest of cables. The labeling's all gone out. There's cables that they just cut out, and just leave hanging in the breeze because they've had to replace a sensor cable, all of that sort of thing. That all goes. What's happening now with the industry, Industry 4.0, is we're taking that one step further. So now where we have that block that you've shown there, that is what we call active, where it has an Ethernet connection, we're now putting IO into that block. So now we're bringing localized intelligence to an area. And what that's allowing machine builders to do, or customers to do, is rather than the factory buying, on CapEx, a machine or a process line or a robot cell or a palletizing cell or whatever it is, the machine manufacturers are looking at this in a new approach. So don't buy it from me, rent it from me. I'm the expert. I know how my machines work. I can have that access through the cloud now through remote monitoring. We can see what's going on there, and we can send, a service engineer in to your factory to service and update it as and when it's needed. The other benefit with that is if they finish, they rip the line out and they change the line for a new, to manufacture a new product, because the factory don't own it, the machine builders take it back. They repurpose what's there, because there's going to be a lot of good equipment that they can still repurpose, maybe for a smaller use factory, or actually repurpose it into something completely different. So there's an environmental impact of repurposing and recycling a machine, rather than what we have in the past, where we just rip it out and we'll send it all to scrap and off we go.
I imagine it also makes the factory environment very flexible. It's not just a case of commissioning it or taking it down. If additional components need to be added, I'm guessing that something like this makes it really easy to add extra modules in, and it's almost a plug and play situation.
Yeah, definitely, David. It's far easier to do any modifications or any additions. I mean, going on the rent buy approach, and modularity. We're actually working with a customer now that's making conveyor systems. Now, as we know, within a factory, a conveyor system is generally purpose-built conveyor fitted around that factory, to do whatever it needs to do. But if you look at what they're now approaching with the modularity that we can do, and with the intelligence that we can put into these blocks as well, is we can say a conveyor system, pretty simple. And forgive me, everybody who's watching it who deals with conveyors, I'm going to really simplify it. You have an on feed, you have a conveyor, moving around. You'll have a right angle, a left angle, a ramp up, a ramp down, and you'll have an off feed. Like I say, really simple. So why don't we, and this is what the customer's looking at, is saying, well, why don't we just build an on feed? Why don't we build a section that's a conveyor section that we can just multiply, an off feed, a right angle, a left angle, a sorter, or whatever we need to do. And then when a customer says to us, we need a new conveyor system, it's basically saying, I need, it's a kitting list. I need an on feed, I need 10 straights, I need a couple of 90s, I need a sorter, and I need an off feed. Plug it all together. And because each individual module has the intelligence and safety incorporated in itself, and with the IoT, or the Industry 4.0 extension, we can now bring in that safety as well. So each of itself looks after its own safety, but they're all talking together real time. And I'm not talking about, today's machines or machines a few years ago. Oh, we have real time machine to machine talking. We don't really. What we have is a controller talking to a master controller that's talking to another controller. We're taking that out and we're putting it all together. So we have that real time machine. And so the functionality, if you look at the efficiencies for the machine builder, I'm making 10 different variants of a module. If you look at how they put it together and commission on site, it's really fast, it's really flexible, and they can do what they need to do on site. When you look at when it's actually in service, if something was to fail or gets broken or gets knocked, or we need to add, change, be flexible in how fast we're producing these conveyors. If you go back to that bread factory, a loaf of wholemeal bread takes longer in the oven than a bun. So we need to have that speed of things going forwards, and we can have the mixers or the production plant saying, now I'm going to introduce a batch of buns into this system. I don't have to stop it. I don't have to go in and readjust or reprogram the controller. I can do it all on the fly. So everything changes, and the flexibility within that smart factory is what they're looking for. And that means that they can get further product out quicker and out faster.
This is a really interesting concept, actually, because it means you've got effectively self-commissioning machines. You plug one conveyor unit, let's use the conveyor example again. You plug one conveyor unit into the part that comes before it, the part that comes after it. Again, you don't need to tell them what's going on. That module will know how the product is being presented to it on the conveyor that was before it. It knows what's going to happen to it afterwards. It becomes very quick. And as you say, being the safety, the machine safety all built into it, you've got this situation where you don't have to test out the safety, the system, all this kind of stuff. It is literally the biggest plug and play Lego set that you can think of. It's just putting module after module, and everything functions smoothly. This is a really interesting concept.
Yeah, and if you expand upon that as well, so if you've got a conveyor system, it's one part of moving product around a factory. But you could have bottling plants, you could have filling machines, you could have mixers, you could have ovens, you could have robot cells that's doing robot welding in car manufacturing. If you look at a car manufacturing plant, they have one line. So they're building, here we are, I'm building a Mini. And within that Mini, there's all the different variants. Yeah, okay, we understand the colors, we understand the trim, we understand the wheels, they all get presented at the right time to that car as it goes through. But as that goes through the line, so we have the actual types of car going through. Does it have a sunroof? Does it have a panoramic sunroof? Is it convertible? Does it have, are there cars that have different applications or need different machines to do certain different things? If we have that all in one line, then if it's not a convertible car, all the machines still have to go through that convertible fitting line. Well, why don't I have it so it spins off? So I take that one out, get the convertible fitted, and feed it back in. So then everything has to talk to each other, so that when I've taken number 100 of the car 100 today out, and then I feed it back in at car 150, I still have to make sure that all the seats, all the wheels and dashboard and everything else is the same as it goes through, and that's the RFID. So that's all more data.
Yes.
All flexible, all changing, all adjusting in real time, with machines talking to each other in real time. And then the access out into the IT world with the databases in real time. That's huge amounts of data, massive amount that we can now pull in. And you can have those machine builders that are making those lines being the experts, renting it to BMW, rather than BMW saying, I'm going to put a new line in and spend, tens of millions in putting a new production line in. And then once it goes, we just bin it all.
Yeah, makes it a much more flexible system. Yeah,
it's hugely flexible as we move forward into modularity. And what we have as well that's helping that move forward is the millennials are coming in. I'm of a certain age, you're of a certain age, David. There's other people that are higher than us, older than us or younger than us. It's been done in this one way for years. And it's the millennials that are coming in now that have grown up with mobile phones, grown up with the internet, never known a world without it, are saying, why can't I see what's happening to this machine on my cell phone? Why can't I get a notification on my cell phone? Why do I have to do all of these connections when I can just plug things in and take things out? Why do I have to rip out a whole machine if I just want to do a modification? Why? And the old school is because we've always done it that way. And with this modularity, we're not expecting, factories of the future or whatever to suddenly rip out everything that they've got and put this new shiny stuff in, because they don't need to, because it's modular. So they can bring it in piece by piece. Ideal situations, greenfields or brownfield site where they're going to put a new factory in. Perfect situation, can really adopt all the infrastructure straight away. But there's a lot of machines out there that have been running for 20 years. But when it starts failing, or they need to take out that bottling plant and put a new bottling plant in, that's when they can make the change. And then they see what they can get out of it and the modularity and how they can adjust things, and the flexibility and the efficiencies of those machines. So it actually brings that capex to replace the other parts of the machine, faster and earlier, because they can see the benefits and the cost savings that they would generate and get in bringing that forwards. So whilst the IoT has been talked about for, Industry 4.0 for quite some years, the technology's not been there, but the technology is right there now. So we're right at the beginning of that sort of peak of the wave as it's coming through. And so we're going to get that as it comes, as machines, as factories, as people want more efficiency so they can be more profitable or even stay in business. You've got the challenges of the world. Everything's connected now. We can see what's going on and how we move it forwards. And that's where you need that established brand. That's where you need, there's an M12 is an M12. It's a AA battery. Yeah, but I can guarantee you, are you using Duracell AA batteries, or are you using Tesco AA batteries? Generally, you'll walk in and say, I want Duracell. And that's because you know the brand. And that's Molex's approach with Brad. Brad, for many years, was the go-to product. It was almost like a Hoover. It was a Brad lead. I need a Brad lead. Now I need an M12. I need a Brad lead. And that's why we're bringing this, focus back in to the Brad from Molex connectivity range. And that's why I know RS are doubling their range of Brad products, because they can see the benefits and they can see this trend into what's coming. And so you guys or RS are bringing themselves and preparing themselves for that future demand.
Mm-hmm. Certainly the Brad name is one that I've been familiar with for as long as I've been hanging around the connector industry. It's definitely been one of those high level brands, the ones that you trust in terms of delivering this kind of connectivity in tough conditions. I keep coming back to the fact that the factory floor, and it doesn't need to just be the factory floor, does it? But this kind of production environment is pretty tough on equipment. It's pretty tough on electronics, and the modern world, this smart revolution, isn't just about factories, is it? There's all sorts of other applications out there, from, I don't know, traffic controls and the smart city to smart grid and power generation. There's a lot of these technologies that are all adopting a similar approach with their data. Is that right?
Yeah, definitely. I mean, you've hit the nail on the head when you're looking at, traffic light systems. How many times have you been in a road with multiple traffic lights in, and one changes green, the other one's red, and there's no flow control? It's like, oh, what's going on? And whereas with all of this technology being able to talk to each other and bring everything together, so we can actually get to that point where if you hit a green light, by the time you get to the next one, it should be green if you're not doing more than the speed limit. And bring that flow of traffic. You've got smart motorways now in the UK where they're monitoring the flow of traffic and they'll adjust the speed automatically, or speed limit, to try and minimize the stuck in traffic. And whilst being on smart motorways, sometimes pain, because you're driving along and it says it's 60 and you think, why is it 60? Well, if it wasn't 60, you'd be sat in that wave traffic jam, the stop start, stop start, stop start. So it does actually get you there quicker. And all of this stuff needs that environmental connectivity. So you've got, IP67 is kind of the default for any connection, whether it's outside or whether it's inside a factory, because you've got all sorts of cutting fluids maybe flying around. You've got in food environments, you've got washdowns, so everything needs to be protected. And that's why IP69K was developed from the agricultural industry, actually, because you got Farmer Joe had all his connections on his tractor and his muck spreader. And what he'd do is he'd say, well, okay, I get my jet wash out, and he hoses it all down. And he, for some reason, I don't know why we do it, if we see an electrical block, box, we'll go in harder and faster and longer on that electrical box than we would do on that panel, just because we do. And that's why IP69 was taken, so that they could use that high pressure from 10 centimeters at all angles. They could bring in high temperature, 80 degrees C to do that wash down. IP67 won't survive the high pressure jet wash. IP69K does. So there is a differentiation. So IP69K is not all encompassing, but as we move forwards, the Ultralock 2.0 and the standard Ultralock that we have now is IP69K. So it doesn't matter what environment they're going into, it will survive.
And that's true of the whole product mix, because we've been talking about M12s, but we've got the larger I/O connectors here.
Yeah,
These
the
are
mini
M23s.
change. Yeah, so it's a 7/8 inch that connector, and that's all IP67. So that block that you held up there, and the MPIS block as well, that one as well, they are both fully IP67. If we connect with the Ultralock onto the box, then those connections are IP69K. But maybe the block isn't. But with the new model that's coming, as we're developing our we call it the IAS 4.0. So with that block, with the intelligence in it, with the safety in it, it's a metal housing. We've taken off those larger power connectors and we're using the L code connector now, which is a new development that, across the range, not just from us, but as a consolidation between manufacturers, where we can bring power, that higher power and higher current through an M12. So we're minimizing things again. And because we can do that, so the next development from the standard signal connectors for the Ultralock 2.0 will be, can we do the same thing with power? We already do it with Ethernet. We already do it with the standard, I/O connections anyway. Can we do it with power? And there's no reason why we can't. So all of a sudden that block is IP67. It's metallized, so it's functional, it's sturdy, it's strong. It has that environmental protection of the intelligence inside it that we need as we move forwards.
Fantastic. So we've got a huge range of products, everything from the tiniest sensor connectors, M5s and M8s, through what appears to be the very standard M12 of varying, it's 3-pin, there's 4-pin, there's 5-pin, different codes to prevent mismating. Then we've got the larger connectors for connection back to the PLCs. There's power connectors we've talked about. We've got the blocks themselves, actually bringing intelligence down towards the machine to remove the need for those ridiculously long cable runs with hundreds and hundreds of wires. There's a little M8, sorry, yes, a little M8 block here as well to show the different types that are available, and as you see the difference in size there. So we've got a pretty complete range. I was going to ask about the Brad. You mentioned Brad earlier on, and the fact that Brad is a name that so many people in the industrial world trust and have done for many, many years. So the fact that Molex believes in that Brad name says a lot about its commitment to the industrial world. I will mention again that RS is doubling their product offer of the Brad product, because then they see the power of that name to the industrial user, and the fact that this is just going to expand. There's going to be more people doing more intelligent and creative things with this technology at the lowest level of the factory floor, and so this level of industrial connectivity is just going to explode over the next 5-10 years. So it's been fascinating to talk to you. I'm hoping everybody's learned a little bit more about some of the innovations that are going along in this industrial connectivity space. If you need to find out more, we have more information here on Design Spark. The Brad product is being introduced, this range expansion we've got within the RS range. Visit the RS website, find out a little bit more about that. I'd like to thank Jeff for his wise counsel and interesting information regarding this. This has opened my eyes to some of this industrial world that I wasn't familiar with. So Jeff, thank you very much. Thank you everyone for watching. Thank you to Molex for helping us out to make this video, and we'll see you again soon.
Thanks, David. Cheers.